Hello, class. Today we will be doing notes on the ideal gas law. So our equation that we've learned so far is called the combined gas law. And the combined gas law says that P1 V1 over T1 equals P2 V2 over T2. And we're going to use something very similar to that, where you're going to recognize a lot of these variables, and it is called the ideal gas law. And the ideal gas law equation is PV equals nRT. And a lot of times I might refer to this as PIVNRT, just a nice little abbreviation. So NPV equals nRT. Pressure is still represented by a P. V is volume. N is something new that we haven't seen. It's something called moles. R is the ideal gas law constant. And that is always going to be the same number, which we'll talk about here in just a second. And T is temperature, just like before. So what is this ideal gas law constant? Well, this ideal gas law constant is R, and it depends on the units of pressure, but we are always going to be using R equals 0.08206. And whenever we use this value of R, our pressure must be in atmospheres. Our temperature must be in Kelvin, and our volume must be in liters. And that's just so that all of our units cancel out correctly. So these problems are what I think is even simpler than the combined gas law problems. And we're just going to plug some numbers in and solve for our missing variable. So if we take a look at this first problem, it says if we have 4 moles, so that would be Rn, at a pressure of 5.65 atmospheres, there's our P, and a volume of 12.5 liters, what is the temperature? So we're looking for T. And you can see here that this is different from ideal gas law, this is different from our combined gas law because we don't have like 2 pressures and 2 volumes and 2 temperatures. We only have one of each thing. So that is our hint that we're going to use PIVNRT here. So PV equals nRT. And we want to make sure things are in the right unit. Our pressure it's in atmospheres. Our volume is in liters, so it's good. Our N is in moles, great. And our temperature we're going to get out is going to be in Kelvin. So let's go ahead and plug this in. So 5.65 is our pressure times our volume, which is 12.5, equals our number of moles, 4, times R, and that's always the same number, 0.08206, and temperature is what we're looking for. So all we have to do in order to solve for T is divide by 4 times our value of R. And over here, those 2 numbers cancel. And so we want to plug into our calculator 5.65 times 12.5 divided by 4, and also divided by our ideal gas law constant. You want to make sure that you're using your calculator correctly when you do this problem. And if you are, you should get a nice number. We'll round it off to the nearest degree, and we'll call it 215. And remember, our unit for temperature is Kelvin. So make sure you practice plugging that into your calculator to make sure that you are doing your calculations correctly. Okay, Let's try number 2. All right, for number 2, if there are 3 moles, so there's our N, an ideal gas in a container with this volume, there's our V, and a temperature of 401 Kelvin, what is the pressure? So PV equals nRT. And check our units. We're in moles, we're in liters, we're in Kelvin. So that means our pressure we're going to get out is going to be in atmospheres. Perfect. So this time we're looking for pressure times volume equals number of moles times our value of R times of temperature. And this time the algebra is even easier. We just need to divide by 60 on both sides. So it should be easier in your calculator this time. So pressure is equal to 3 times 0.08206 times 401 divided by 60. And I'll just round this answer to 2 decimal places, so I'll call it 1.65. And remember, our unit for pressure in ideal gas law is always going to be atmospheres, or ATM. Lovely. Okay, let's try solving for one more variable. Let's try this third problem here. So the pressure is 4.54 liters. Liters is going to be our volume. And then here's the pressure. And the container's at standard temperature. Ooh, we have to remember what that means. If you remember from our notes, STP was standard temperature and pressure, and our standard temperature was 273 Kelvin. That was from our very first set of notes in this unit. And it wants to know how many moles, and that's going to be our letter N. So once again, we've got PV equals nRT. This time we're going to solve for our N. So we have 1.26 times 4.54. We're looking for N. Our R is always that 0.08206. And our temperature this time is 273. So what we want to do is we want to divide both sides by our value of R and our temperature. And when we do this in our calculator, and make sure that you do it in your calculator so that you make sure you're plugging it in correctly. And I get 0.254 moles, which you can just abbreviate MOL, or you can write out moles the whole way. Thank you.